So I'm here on a partly cloudy day, a beautiful day. It's going to be, I hope, mid-afternoon after having a morning of talks at the Cosmic Streams in the Era Rubin conference with a longtime source who I first met in 2010 in South Africa, the former director of the SALT telescope, which is the largest telescope in South Africa, if I'm not incorrect.
In the southern hemisphere at the moment.
In the southern hemisphere, David Buckley, who has changed his focus a little bit from being director of the telescope to being the principal investigator of transient follow-ups with SALT. Is that how are you to identify yourself, David?
Yeah, that's basically, I'm the sort of lead investigator for this big program on SALT that is doing observations of transients.
And tell us what a transient is for people who don't know.
Yeah, transient is really something which has suddenly come into existence where we didn't know of anything before, or even a wider definition is anything that is sort of varying as well. So,
in brightness, in other
brightness,
words. So if you're looking at a dark sky and you suddenly see
something new,
an object
like a nova or a supernova, even a planetary, comet or something, you could classify as a transient.
And you have been using your instruments of spectroscopy on SALT to do follow-up analysis for transients that have been detected by other telescopes. And this has been going on for how long?
Well, we started in 2016.
16.
So, yeah.
And you're just adding a new instrument, the near walls?
Yes, so we have been basically using the three instruments that were first installed on SALT, but just this year we've installed a new infrared instrument built at the University of Wisconsin in Madison, and that extends it into the infrared. So we're just beginning to start using that instrument as an additional tool in the study of transients.
And you were telling me that there are two types of objects which are probably not that well known to the general public. One, everybody knows what a supernova is, but tell us what a nova is. It's different than a supernova.
A nova is something far less energetic than a supernova, as the name might suggest, and is basically, it's a binary star in which there is accretion happening between from an object in orbit around the white dwarf, like a solar type star, like the sun.
So it's a white dwarf.
It's a compact star like a white dwarf,
okay,
which is about the size of the Earth.
All right.
And it's in a close orbit, typically a couple of hours.
But white dwarfs are extraordinarily dense.
Very dense, very hot.
Very hot.
Typically, and so they're in such close orbit that the material from the companion star, which is like the sun,
it's a normal hydrogen-burning star.
Normal hydrogen-burning star is being stripped off and forms this sort of accretion disk that surrounds the white dwarf.
Accretion disk of hydrogen.
Yeah, right. Mostly hydrogen gas, which heats up as it gets further in. It sort of spirals in, and eventually it's accreted onto the surface of the white dwarf. And what happens over time is as that mass builds up and the temperature of that gas gets to a certain critical temperature and a critical density, then all of that accreted material just suddenly ignites in a thermonuclear flash.
But it doesn't destroy the star.
It doesn't destroy the star, but it causes a large sort of outflow of material, like an expanding shell of material.
Right.
And that's what we see as the bright, sudden increase in brightness due to this expanding bright shell of material. And then it can interact with the circumstellar material around the binary star and cause all sorts of other emissions, and higher energies, even in gamma rays, have been detected in recent times.
And our own sun will eventually turn into a red giant with a white dwarf at its center?
Yes, but it'll go through probably a planetary nebula phase where it sort of expels an outer envelope of the star. But it's not a binary, so it won't go through.
It will never be a nova. But
Yeah.
historically, novas were first probably detected
By the Chinese
by
and
the
the Korean
Chinese who note them. Yes.
astronomers back in the day, and of course they didn't really know what they were, and the word nova just comes from new star, and then we sort of started to learn more about them when we started doing astrophysics on them, in this last century or in the early part of the 20th century. And then supernova, another class altogether. You might think they're very similar because of the name, but they're not. They're a case where a white dwarf reaches a critical mass and the whole star collapses and causes an enormous explosion, much more energetic than a nova.
And the LSST, the Vera Rubin Observatory in the north of Chile, which is supposed to come online in 2025 with pure science observations, not just commissioning phase, is going to create an embarrassment of riches for you, because you have 10% of the telescope time at SALT for observing transients, and every night the Rubin Observatory is going to detect 10 million transient events. So what are you going to do?
Where we're going to be relying on machine learning and artificial intelligence to tell us of those 10 million alerts, which ones are the most interesting to follow up. Of course, many of them will be very, very faint and not even possible to follow up with, even with a 10-meter telescope like SALT. But we need to apply these techniques where you take the human out of the loop, where you have machine learning that tells you on the basis of whatever information you have and the knowledge you have of the behavior of certain classes of object. On the basis of that, what is the evidence for it to be a nova or some other type of object?
So we don't have to worry about postdocs fighting at the telescope for observational time.
There may still be different people who want to use the telescope for different purposes, but there's always that tension. Yeah.
So give us a little bit of a preview of a future project that the SAAO is going to be doing also for transients. You mentioned this in your talk earlier too.
Yeah, so this is a project that's been going now for about 3 years, and it's called the Intelligent Observatory, and basically it's linking together all of the telescopes that we have up at the observing site in Sutherland. So we have telescopes dating back to, I think the first one was the 74-inch telescope that was built in 1948, to the latest one that was a 1-meter telescope built about 3 years ago. And all of these are in different phases of being linked together into this network of basically autonomous telescopes that can do observations in a robotic sense. So on the basis of having alerts that come in from what we call alert brokers that tell us about transient alerts, then we have systems that interrogate those, decide what likely object that is, and therefore what is the most appropriate telescope to then follow it up with.
And this is done at very high speed.
Well, it has to happen almost in real time.
Almost
because,
in real time.
Many of these transients are fast events, and so some of the more interesting and energetic ones are by definition things that you have to get on to immediately. Other ones, not so much. You might have, be able to spend days before you observe other ones. But the idea is that you make the whole system more efficient, and you take the sort of human out of the loop, which makes the whole thing a lot more efficient and expandable as well. So this project is going on in South Africa, but it's also planned to expand it throughout, the African continent, but also globally as well, because there are many other observatories in the world that are be doing similar science of trying to follow up things, and the last thing we want to do is sort of waste resources on duplicating effort. So
exactly.
If you can have some system that allows you to decide which is the most appropriate telescopes to do certain observations, it's a more efficient way of doing it, and in the end, science wins out.
So thank you so much, David. Serendipity. I had no idea you would be at this meeting, but serendipity seeing you 13 years after we first met, and I'm glad that you're still very much involved in professional astronomy.
Thanks, Bruce.
Thank
Yeah.
you so much.
Okay, not at all.